Good morning, everyone, and welcome to today's DIH Talk. My name is Santiago Uribe Diaz, and I'm a Digital Transformation Advisor at Lux Innovation. Today's DIH Talk is being co-hosted with our friends from Germany, from Edi Sarlan and the FKI. We have with us Ilka Wilk and Daniel Porta. Welcome.
Hi.
So, for those of you who are new to this platform, there is a discussion window where you can interact through the session with us, with the users. And there is also a questions window where we encourage you to post all the questions that you have. And at the end, we will have a Q&A where the speakers will answer to all these questions. Today's topic is human-robot collaboration and industrial AI. This is a very interesting topic. I'm sure most of you, if not everyone, has been hearing a lot in the past months and years about AI and robots. So today is an excellent opportunity for us to discover what are the latest researches in these topics and how is this changing the industrial world and the way we work. And yeah, we will explore how we as humans can collaborate with robots and AI to be productive together and get the most out of these technologies. So now I'll give you a small intro about the services of the DIH Luxembourg. We are the Digital Innovation Hub, and our mission is to digitalize the small and medium-sized companies in Luxembourg. All our services are 100% financed by the EU and Luxembourg. No invoices, no administrative procedures. It's very easy for you. And we achieve digitalization for companies in different ways. We have assessments. These are questionnaires that you can fill online or with our help in your facilities. And the idea of this assessment is for you to discover in which direction you should orient your digitalization to be more productive. Depending on your answers, maybe you discover that an ERP is a good idea for your company, or more cybersecurity, etc. The idea is to guide you on this journey. Then for cybersecurity, we work together with the Luxembourg House of Cybersecurity. They also have an assessment. You can discover how good or how bad is the cybersecurity in your company. And they can do workshops for you to advise you and to give you some recommendations to improve in cybersecurity and be more protected. And there is also the room 42. This is a physical room in the LHC where you can go with the staff of your company and simulate a cyber attack with the data of your company. So it's an excellent opportunity for you to be prepared and know what to do on a real attack. So don't hesitate to reach out to the LHC if you're interested in this opportunity. In skills and trainings, we work with the University of Luxembourg. They can help you do training roadmaps for your company and analyze which are the most pertinent trainings for your staff. On technology tests, we work with the list. We know that it's a considerable amount of money when we invest on digital technologies. So if you have something in mind, like buying a new software or a robot, etc., you can reach out with the list and they can help you test this technology before you actually invest your money and use it on your factory. That way you can know if it's a good idea or if you could look to other options. And finally, we also help in terms of awareness on funding. We do similar webinars like the one from today, but oriented to let you know which are the funding opportunities from the government of Luxembourg for your company. And now I want to ask you for your help. We're trying to discover which is the preferred language for these sessions, because we have people that speak English, French, and German. So if you want to vote, it's very easy. You just need to scan the QR that you see on the screen and answer which is the preferred language, English, French, or German. I leave it a few seconds before we pass to the next part. Okay, thank you very much. So now I will let our colleague Ilka present you what are the opportunities from the Edi Sarland.
Thank you, Santiago. Good morning, everyone. My name is Ilka Wilk, and I work as a communications and event manager at L-DIH Saarland. L-DIH Saarland is one of the many digital innovation hubs in Europe that helps small to medium-sized companies, SMEs, startups, and mid-caps to successfully use AI for the process and operations. So please, next slide.
Yes.
Thank you. Our services. So our services do not include dedicated trainings for companies, but also support with development and implementation of AI solutions. That can be testing, so you have the chance to test a solution before you would invest into it. That can also be the development of a prototype solution or hands-on support with implementing a solution. Last but not least, we also offer support in finding funding or investors to finance the development of implementation of your AI solution. So next slide, please. So our customers, as indicated before, our customers come from a wide range of industry sectors. However, we also support the public sector in taking up AI and digitalization further. So next, thank you. The engagement with our customers typically starts with a simple contact as a part of one of our events or through our website or through social media. Together with our clients, we then analyze their processes and identify most promising opportunities for the use of AI and or digitalization in their organization. Following a thorough process and feasibility analysis, we then draw up a dedicated AI and digitalization roadmap for our customers. Last but not least, depending on each individual case, we will finally assist with prototyping, testing, and or actual implementing of the AI and digitalization project. In terms of areas covered, as already shown before, we can support virtually any AI application area and industry sector. But today, we would like to focus on production topics and what is possible with regard to human-robot collaboration. So thank you for your attention, and if there are no questions, I will hand over to my colleague, Dr. Daniel Porter, who will provide you the latest insights from our MRK lab. Thank you.
Thank you, Ilka.
Thank you.
So yes, please join us in welcoming the speaker of the day, Dr. Daniel Porta. He works in Future Applied Industrial AI at DFKI. Welcome, Daniel.
Yeah, thanks for having us here. That's a really great opportunity to show what we are doing. I want to briefly introduce myself. I'm Daniel. I'm working for DFKI almost now 20 years as a researcher in various positions. My background is in computer science. When I studied, we had a diploma study, so I had to have a subject, and that was engineering. So actually, it fits quite well. And I want to directly jump into my presentation. I need to share my whole screen because I have some videos. So I hope it's not too boring for us when I click through the slides. So what we do here, or what we see here, is our human-robot collaboration lab. So we are working there as a research group within our research department, Cognitive Assistance. I'll show you a little bit later because I want to introduce also DFKI to you. And so I'm co-leading this research group of about, let's say, 20 people, also in various positions, as we have Ilka here, so she's also part of the group, working also for the ED, and that is a very good mix actually. So DFKI in general, yeah, we claim at least we're the world's largest public research center on AI, and we have different sites, so or multiple sites, and we have grown over the years. So I'm sitting in Saarbrücken, yeah, but we also have premises in Kaiserslautern, Darmstadt, Bremen, Berlin, also with an office, and most recently actually Osnabrück, Oldenburg, and Lübeck, and Trier as well. So quite close also to Luxembourg, right? And in these different premises, we have different research groups. Yeah, so we cover actually the whole spectrum of AI. Nowadays, AI, yeah, people think it's only generative AI, but that's actually not true. It's a long history, but of course, it's very prominent right now. And I'm personally, as I said, I'm affiliated with the Cognitive Assistance Research Department, which is at the same time headed by our overall DFKI CEO, Professor Antonio Krüger. Yeah, and I'm heading a research team inside that research department. Yeah, so in general, we are about 100 and 500 people. That is a combination of full employed staff, but also student researchers. The numbers look kind of impressive, but it's always, as a research institute, it's always depending on how much money is in the system. So last 2 years in Germany were a bit hard, but now it's getting better again. Also with getting to know that AI is important, and sovereignty, AI sovereignty is also very important. DFKI is a joint venture, so we are owned by these companies that you see here, and among these companies there are a lot of car manufacturers, let's say, but also IT companies like SAP, but also the big companies like Google, Intel, Microsoft, but also industry companies, like Bosch, ZF, so good mixture, and that means we actually are a non-profit company. That means we're doing research projects that are publicly funded, but we also have the order, so to say, in order to do industry projects with shareholders, but also with everybody that approaches us. So we cover the full spectrum from basic research to industrial applications. We have these. So every research department is headed by a professor, and that enables us to do this basic research. Within DFKI, we transform that into application-oriented research that we finally transfer into the industry. So in terms of shareholders, but also other clients. And we also do, of course, spin-off companies. Having said that, our service offering basically is quite broad. That goes from doing some studies up to implementing live product functionalities and everything in between, basically. Okay, coming back to our lab, our human robot collaboration lab. We had our 10th anniversary basically this year, and we were so in stress with doing projects that we actually forgot about this. We need to kind of celebrate this in a more formal manner, I guess. But initially, it was funded by the German Ministry for Education and Research, also in an endeavor to work closely together with our colleagues in the Czech Republic. And I also show some projects that we did together with these guys. It is located in an ABB factory hall, a former factory hall, that has been renovated and is now fully committed to showing demonstrations and to doing research in this environment. Quite a nice environment. We do this together with the CEMA Institute, the Center for Mechatronics and Automation Technology, which is currently transformed. Probably you heard about this, but most likely not. Which is currently transformed into the Saarland Engineering Institute. So kind of a larger umbrella, and we will be part of that with this this facility that you see here on the screen. In this lab, what do we do there? We have 4 pillars, let's say. One pillar is we're researching on standardized architectures, infrastructures for the industry, for Industry 4.0, how we say. It means we use or we implement digital twins, and we do this by relying on this standard asset administration shell, which covers, I don't want to go too deep into that because it's not part of today's topic, but it covers the whole life cycle of an asset, and you can, whenever you have something, you can attach new information to that administration shell for a certain asset, and you can also retrieve that information whenever you want to have it. So, and this kind of accumulates information across or along the whole life cycle of assets. Based on that, because then we have a digitalized, standardized infrastructure, we do actually our industrial AI research. And this is not only human-robot collaboration or telerobotics. We also do research in process optimization, supply chain optimization, supply chain resilience, worker assistance and safety, but also quality control and also compliance, which is important for industrial applications. For that we use our kind of large-scale evaluation demonstration environment. We have quite a lot of robots there, so 20 plus is stated on the slide, probably some more in the meantime. Also intentionally different for robots from different manufacturers. We have ABBs, we have robots from KUKA and others as well. This is important also for this architecture thing, because we want to abstract away from this. We don't want to rely on a single platform. And lastly, industry cooperation transfer. As I said, this is kind of very important part of the DNA of DFKI. So we do this consulting qualification stuff in combination, with the ED Saarland, but also other projects like the regional Future Center for AI and Digitalization, so RZZKI here, and others. And we also do open source software. So there's also a good way for us to distribute what we do. Just have a look if you like. Good, but today it's about human-robot collaboration, and of course we can ask ourselves why actually is this important, because it appears to be quite complicated. But other things are more complicated actually, because we have labor shortage or skilled labor shortage. Actually, we have partners. Let's say we have labor shortage. They take everybody. Just need to have 2 arms basically. Skilled labor shortage is, of course, the most prominent factor. So you can't fully automate things, because you have companies, or you have products that have a high variation but a low volume. So you do this kind of, there is no return on investment if you fully automate this. And the question is how can you do it better? With human-robot collaboration, probably it doesn't fit to everything, but most likely it can help you, because it gives you the opportunity to better use your human resources, so to say. And because AI has kind of matured over the last decade, this is actually a good thing to combine them. So I will talk also about this in a couple of slides. So basically, when you go into a factory, you see the robots, they are caged in order to be safe. Yeah, what we want to do is we tear down the cage, and enable humans and robots to work together as a team. And in order for you to distinguish between different facets of human-robot collaboration, I want to also briefly introduce kind of a collaboration spectrum, such that you are aware of certain types of human-robot collaboration. So first of all, we have the cell, which is actually no human-robot collaboration, right? So the robot is fenced, and there is no shared physical space between a human and a robot. That's how this is done typically today. You all know about this. Then you have kind of a coexistence. You have some shared space, but you have separated tasks. So human workers are doing different things than robots, and you have shared time. So humans and robots basically don't meet. Then you have cooperation. That means you have a shared workspace, and you have sequential tasks, but on the same part. So kind of the robot is doing a certain task, and then the human takes over again, and vice versa. And then you have the most complicated thing, collaboration. You have a shared workspace and you have shared tasks, and you do this simultaneously with robots. And you have, this is contact rich. It means you may touch the robots, which is inherently dangerous. you might think, because today, if you touch a robot, typically the system stops. So there is no way to go further. There is a emergency stop, and you have to call a technician to get it running again. Also with the collaborative robots, they are quite. The collaborative robots, they will stop. The other ones won't. So they kind of rip off your arm or something. So, as I said, the hard problems, they are on the right side, but also the biggest chances, they're also on the right side if you do it correctly, or if you do it in the right way. You need to enable safety. You need to also enable intuitive interaction, because otherwise humans won't accept it. And you do this, of course, with all kinds of AI techniques. Okay, so basically, building blocks of such human-robot collaboration is kind of a perceive, understand, and act loop, or react loop. You use vision and sensors in the environment to perceive the environment, and then you try to understand the context and the intent, and then you act on this. And that means you plan, and you have different levels of planning. So you have a quite macro planning level, where you just think about which skills to concatenate, and then within each skill, basically, or macro step, you have, of course, things like motion control and really reacting very fast to unforeseen things. That then turns a robot from a pre-programmed arm into a adaptive teammate, basically. And let's go deeper into these three boxes. So as I said, perception and safety, you use 3D vision or sensors, everything that helps you to perceive basically the environment. And you also have a separation, basically. So you need to kind of adapt also the robot to enable safety. It means whenever you perceive that a robot or that a human comes close to a robot, you might slow down the robot a bit, because that that adds to a kind of perceived safety, so the human feels safe, and if he's or she's feeling safe, this is I mean, you want to have this, because if you have people working that don't feel safe, they probably don't want to do this any longer. Yeah, so this is very important. And yeah, why is this hard? Because of, it's a real world problem. Yeah, you have occlusion, you have latency in your network, and you have certification. So, I mean, just because you do human robot collaboration, that doesn't mean you don't need to think about certification. Actually, it's the other way around. You need to think more about this. But you need to find a kind of a sweet spot, in order to not to be too cautious, but also you don't have to be too bold, because then it's unsafe again. And somebody in the end needs to sign that it's safe. Okay, understand. That means whenever you perceive something, you have a context, and you need to understand, or try to understand, what the human worker is going to do, which part he wants to take, which task he wants to perform, how does that fit into the overall production plan, and so on. You need to anticipate this and build up your context model. And of course, there is some ambiguity, inherent ambiguity. You have individual differences. Every person is different. You can't really generalize there. You have and we have that of use cases on that as well. You have persons with disabilities, and you need to reflect this. You need to kind of take care of this in your system, in order to work properly. So, and then people don't follow the script, so they basically learn something, and they adapt on what they learned over time, because also they want to improve. And probably the initial plan that you told them was not the best plan, so they try to, let's say, rearrange material boxes as they think it's better for them. So you need to really take this into account. This is not a static environment they're in. Okay, and then act and adapt. You have skill-based control. As I said, this is a macro level. You build reusable blocks like pick and place, or inserting a screw. This breaks up monolithic spaghetti code, as we call it, on the PLCs. Because you take this then to a higher level orchestration, and you can reuse that, but you can still rely on real-time things directly on the PLC. So this is the first step. You can also then do programming by demonstration. We also have use cases on that, where a worker just shows a robot what the robot is supposed to do, and nowadays, this is kind of shifting towards using foundation models for these kind of tasks. You have kind of chatbots, large language model interfaces that you can talk to. You also have vision language or vision action models that are built into robots, into mostly humanoid robots, such that they can really act on their own. I think yesterday I saw a new model from Quen being released. And you have also agentic planning, where you use a large language model for planning steps. Of course, you need to have the human in the loop in this case. The question is, why do we do that? Because it inherently adds more unsafety, or things that you can't control, because it has even more statistics involved. But it turns out, actually, modeling everything explicitly was not very successful, because it's tedious, and you can realize only small use cases. So using this kind of frontier models or models in general, large language models, that abstracts away modeling complexity. You don't need to, because it's already learned in the model somehow, but you really can't grasp it. So still the factory bar is on reliability, safety, and explainability. So we really need to work on this as well, because otherwise you have nice demonstrations, but you can't sell it because nobody will sign it. Okay. Now let's go into, for the rest of the talk, into some videos where you might see or might recognize things that I've said so far. So here, for instance, and this is always kind of embedded into research projects that we did. You see, okay, object recognition with a camera where you can identify certain objects that you need for your production process. Or here we have a demonstration where we kind of observe the user in performing tasks and try to anticipate where the user is going to reach, in which box he is going to reach, and which material he's going to take out, and then we can immediately tell, okay, I think you are reaching into the wrong box. Please don't take material out, because the idea is for the quality control to avoid errors as early as possible, and that's one idea, to really incrementally assess the quality of the product, which can be derived by the quality of tasks that you do. Okay. Then from other projects, we have this use case. Okay, the robot is really assisting a human worker in holding parts in place, especially when he's working over his own head, which is it's exhausting over time. We did this together with Airbus, so this is kind of an airplane wing, and you need to assemble raceways. This is kind of a part where you will put wires, I think, into. And the other robot just brought the screwdriver, and has a smart watch where you get some information. Also from that project, we have robots working together. So we have this mill platform, mobile industrial robot that can autonomously transport things in factory halls. And we use these kind of logistic robots quite often. So also here, the idea is, okay, the robot is holding the raceway. Then the worker is informed. He do some fine manipulation while the robot is still holding it, and then he puts some screws into that. And when this is done, you see, okay, the robot is notified. Okay, I'm done. You can now leave. Also with Brötche in the airplane manufacturing, there is this idea of having a robot placing rivets and also doing quality control on these rivets. And you have a human worker that is equipped with a AR class, and so they can basically work together at the same, because this is a quite large part, so it is possible that the robot is working next to a human worker, and there is some quality check, and then the robot is doing basically the rest. So it's kind of sealing the rivets such that they don't corrode over time. Okay, I need to go a bit faster, I guess. That was Let me go back. Okay. Then we have this skill-based approach where we divide skills of assets into bigger chunks that we can. Oh, come on. That we can orchestrate on a higher level. So, for instance, what we do here, okay, we say the mill here is broken down. We start this drone, and this drone is modeled or is represented by such an asset administration shell that I mentioned, and that means we know about the skills of this drone. We all need to represent every asset with the same control pattern. So we use kind of control components, how we call them. They have this state automaton inside, and we can use then also standard, in this case, BPMN processes in order to orchestrate such processes. Yeah, that's how we do it for deterministic demonstrations, so to say. Okay. What we haven't done so far is, or we haven't seen so far, is a visual digital twin. So in this very short video, yeah, here my colleague Andy is manipulating this ABB robot, and you see it immediately, basically, also here in the virtual environment, because we have a very fast event streaming where we can replay the position updates in the virtual world. That adds up to, so this is kind of pays into, we are building the context of the real environment in the virtual world. And this is what we can see here. Then we have simulation capabilities. We have a human worker with a HoloLens, in this case, walking through our lab. And we see the position updates here on the large screen. And there is a virtual mirror coming around. This is not real. It's just, it's an illusion, basically. However, so it is kind of simulated, however, this simulated virtual robot here takes into account the real position of the user that is standing here. You see that when, so in this case, he's planning around the human worker in order not to harm him. So there's kind of, it merges somehow together, the virtual world and real world, and you can use then the virtual world to really to really reason about what's going on in the real world, and use that as a baseline for your planning and stuff. This is not so important. I skip this here. Also, safety is important, and perceived safety is important, as I said. We have a human worker standing in front of it's a press thing. So there is a virtual press coming down. We didn't buy this, but then there is also this robot coming close to the human worker, because robot wants to bring something or so. And wearing his HoloLens, because it's a loud environment. He gets a notification that this mobile robot is approaching him from behind. So he's not surprised when he suddenly turns around or so. And this is all in the same digital twin environment. So it's nothing. There is no. This is actually all. A whole demonstration, what I showed you so far, is all integrated, basically, but different parts of the demonstration. Then with our Czech colleagues in Prague, in this case, we do some work on remote human-robot collaboration with robotic embodiment. It means here, colleague in front is standing on a stage in Prague, in the Czech Institute. He is wearing a MetaQuest, and he can control the robot placed in Saarbrücken. You see that now on the left side. And in order to do so, he gets a video stream of the point cloud that is transmitted from Saarbrücken to Prague. And of course, there is some latency involved because of the network, yeah, because every frame is kind of 100 megabytes or so. So there is inherently some latency. But as I said, intuitive interaction is very important. He can very good adapt to this latency because the point cloud is overlaid with the real 3D model. So what you as a human wants to do is you want to really try to keep that to have the 3D model and the point cloud really accurate on top of each other, such there is no fading, and that works pretty well, quite impressive. What else do we have? What is actually time? Okay, 15 minutes. Okay, then project from last year, our iQuama project that we did in cooperation also with Volkswagen. The idea here was to take care of the gap sizes and so of the car body, of the doors and so on. They need to be equally distributed, not only because it's more appealing, it looks nicer, but also because you want to save energy, you want to reduce wind noises, and you want to apply equal force to the ceiling, because otherwise you have water coming into the car, which is the least thing that you want to have. So the question is, how can you do this in a single shot? Because it's quite complicated to do this in a single shot. You have measurement data over the whole production, but still there is some things you can't control, basically. So you need to really be careful. And what we did here is we also had this chatbot, yeah, that you can use as an entry point, as your interface to the digital environment. You can ask this Pepper robot about the car body. So where is the problem? What is the status of the door? Is it open? Is it closed? You see, we have for perceiving stuff, we have placed. Basically, we have the camera on top of, so in a bird's eye perspective, down to the car body. So you basically do what you've been told here in terms of process. And finally, unfortunately, we haven't this in the video. Finally, what is then is coming. There is a robot coming that is equipped with a laser measurement tool, and it can immediately see whether the changes that you made to the door hinges are appropriate or not. And actually, before you reinstall the door, you can check whether it's worth to reinstall the door, or you need to rework on that again. So also there is a robot quality control, or a robotic quality control, that is kind of moving around in the factory and then inspects what the human worker did in order to be done in the first with the first correction. So you can be faster and more efficient in the end. Okay. Now, as I said, large language models are entering the factory floor, and we are supporting this as well. So we are part of this SOFI project. It's on sovereign. It's about sovereign open source foundation models. Yeah, the acronym is kind of arbitrary, but nevertheless, the goal is to develop a fully open family of foundation models and combine this with a self-improving agentic framework that both are sort of the models and the framework. They are both especially appropriate for industrial applications. It's a quite short project with a high budget. And this week we entered the closed beta stage. So there was a press release, and if you want to try it out, you can reach out to I should have put it on the slide, to an email address contact@sophie.info. And then you can basically apply for being a beta tester. We have the models on Hugging Face and some projects, also code projects on GitHub. And the idea is to really use this in industrial applications. For training the model, we used the NVIDIA Nemotron pipeline, and it turned out that with a proper curation of data and so on, we are actually better than, not in every probably benchmark, but in most benchmarks we are better than the Nemotron model, which is quite impressive. Yeah, so this is really in 10 months or so right now, very good result. Lastly, I want to show you a little bit more how the lab looks like, and honestly, an hour before this meeting, I found out that there is a virtual tour through the CEMA. So it's really nice. You can go to rundgang.cema.de. And you see here what is going on in our lab. Yeah, as I said, everything is kind of integrated. I just double click so I can, so full screen. So we have here our UR10. We have another I think this is UR5. We have a mobile UR3 attached to a mirror platform. We have a cooker. I think this one is broken right now, I'm not sure, but so it happens all the time. And we have some fancy older ones, which however are from their capabilities quite nice, because they have more sensors than others. Yeah, so, but not really something that you want to put in your factory. And we can move a little bit around here. We have a Panda robot as well, and I think we can move around. You see other installations that we have. So basically, this is where we were here in the MRK lab, and here you see our installation with the car body. It's a Volkswagen Tiguan car body that he gave to us. And nice. I think you. Do you see? Here is the camera I told you. Yeah. So this is the camera that is observing this car body. Good. And there is then a beamer a projector that highlights certain parts here, and it's a quite nice, large, impressive installation. And I want to also point you to this one here. So also you have this UR robot here, and now it's working together with Hansa, a colleague of mine from CEMA, and they're both now assembling these PCBs into boxes. Yeah, so we have some kind of projects, processes, and products that we reuse across different projects. Assembling a PCB in a box is one of them. Okay. Some other things. So you see the rivet stuff here for the airplane, and some other things. Something else interesting. Yeah, so you can go on this website on your own and have a look around. our offices as DFKI, because we are here in this red office here, and we can observe basically everything that's going on the shop floor. So actually, it appears as a real, as if it's a real production environment. Having said this, let's go back to the slides. So what is my conclusion? So I said human-robot collaboration, it can increase productivity, not necessarily for every use case, but there are indeed use cases where it can increase productivity. It needs to be safe, and you need to have an intuitive interaction, and AI can help you there, but you need to know how to do it basically. And I would claim we know how to do it. Yeah, we did this already in many prototypes, in many POCs, and as you heard also from the DIHs, test before invest is a good thing to try out, because it doesn't cost you anything, just an email basically that you write in order to get into the loop and yeah, test before invest basically. So thanks a lot for your attention. I haven't seen any questions so far because my screen is fully occupied with my slides. So I will then go back and the presentation and see what is going on in the, here it was. Basically, here we are, okay.
Thank you so much, Daniel. Very interesting presentation.
Yeah, thanks. I'll shut this down, okay.
So, indeed, there are no questions in the questions tab. I have one.
Yeah, go ahead.
I was thinking about like cybersecurity.
Yeah.
If we think about it, that could be an issue, of course, because potentially a hacker could use all these systems and damage the companies. So, what are your recommendations when people use all these technologies together with humans to be protected?
Yeah, I guess in general, this division between IT and OT, yeah, which is omnipresent in industry, this is a good thing. So you need to decouple your production IT from everything else. This is because then you don't have intruders. This is, I think, still valid today, or even more valid than it was 20 years ago, basically. Security is very important in our research scenarios. Honestly, we also use ROS, yeah, and older versions of ROS, which we know about. Okay, this is not so secure. You have, because it's more like an easy platform for connecting things. ROS 2 or industrial ROS is more safe here, but I mean, security, you need to think about proper security at every step of such projects, because there are a lot of attack vectors that you can exploit if you don't do it right. I'm not the security expert, but you will. So as a researcher, in AI researcher, basically, you will be an expert quite soon. So at least for the 80%, let's say, the 20%. I mean, this is something for professionals, and I'm not a professional in this field.
Oh, very good. It's a good insight.
But you need to, yeah. But you need to dare to. You need to be honest to yourself. So this, I think, also a very good lesson. Don't think that you can also, if you are good in AI, you can do security. That's not true.
No, I mean, it's always good to have people from every field, of course, as I'm sure you have, and yet together the system becomes great in every aspect, not just production, but security and collaboration, right, at the end. Okay. Well, thank you. Thank you so much, Daniel. It was really interesting. And thank you, Ilka, for presenting the activities of the EDI Saarland. This is beneficial for the greater region, and this can help other companies, not just in Germany, also in Luxembourg. And yeah, together we can profit from one another.
Yeah, great. I would be happy to hear something from somebody. Yeah, today that would be nice. Otherwise, I would say that we will keep in contact and see what happens.
Thank you. So here you can scan the next events of the DIH. And as Daniel says, let's keep everyone in contact. Thank you so much for your participations.
Thank you.
Thanks for having us. Bye bye.
Thank you. Bye.
Bye.